Good morning, guys. So today we are continuing with the lesson on electricity, chapter number 12, Textual Numericals. These are on page number 221. Okay, I'm going to do them because these are important ones and a lot of students find difficulty with these kind of numericals. All right, now look at the first one out there. The first numerical on page number 221. A piece of wire of resistance R is cut into 5 equal parts. These parts are then connected in parallel. If the equivalent resistance of this combination is R dash, then the ratio of R upon R dash is what? Alright, see, first of all, in this case, think about this way, that you got a resistance, okay, this way. A resistance wire. This is your resistance wire, a piece of wire of resistance R. Its resistance is R, okay. Now it is cut into 5 equal pieces. 1, 2, 3, 4 and 5. Okay, 5 equal pieces. Alright, so if its resistance is R, then each one, you see, they are all connected in parallel. Now they are connected in parallel. Connected in parallel. They are connected in parallel, so obviously their resistance is going to go down. Okay, it will decrease when they are connected in parallel. So supposing you want to find this is its resistance is say R dash, the resistance when they are connected in parallel. So when this resistance, let us suppose it is equal to 5 ohms. Okay, now each one will become 1 ohm, each one. Okay, 1 ohm each one. So what will happen is R dash 1 upon R dash will be equal to 1 upon 1 plus 1 upon 1 plus 1 upon 1 plus 1 upon 1 5 times, because there are 5 of 1 ohm each. Okay, so now what will happen is this becomes 1 upon 1 is 1, 1 upon 1, this is equal to 5 upon 1. So therefore R dash will be equal to 1 upon 5. So therefore R upon R dash, R is equal to 5 ohms. Okay, R dash is equal to 1 upon 5. 5 5 da 5 ऊपर आ जाएगा, 25 upon 1 or 25. Okay, what is the then the ratio? It is a ratio and therefore not ohm, it is just 25. A ratio is a pure number. So R upon R dash is equal to 25. Now let us take the second case. Okay, which of the following term does not represent electrical power? See, power is equal to V into I. Okay, so and also we know that V is equal to I into R. So in place of V, if I put IR, okay, if I put IR into I get I square R. Okay, or P is equal to V into I. In place of V, I put IR. I have done that. Okay, in place of I, if I put V upon R. Okay, in place of I will be equal to V upon R. So if I put V upon R, I get V square upon R. Okay, so I got this, I got this, and I have of course this also. But look at what is given in the option. I square R, you can see it is possible. IR square is not possible. Okay, IR square is not possible. This one is not possible. You will not get this resistance. Okay, this one is not possible. It does not represent. It does not represent. That is, this one is IR square is option B. B is not possible. Okay, B will not be possible because of these configurations. All right, let's look at this was number 2. Now number 3. An electric bulb is rated 220 volts and 100 watts. Okay, so 220 volts. Bulb is represented. A bulb has a rating of 220 volts and 100 watts. So power is 100 watts. Okay, when it is operated 100, what will be the power consumed? Now you can see, therefore power, okay, in this case remember power is equal to V into I. Okay, but V into I means what? You can also use V is equal to I into R. Okay, V is equal to I into R. Okay, but V is given, power is given, I is you want to find out. So supposing P, if P is equal to 100, V is given as 220 into I. Okay, so I will be equal to 100 upon 220. So many amperes. Also, we know that V is equal to I into R. Okay, V is equal to I into R. So resistance of the bulb will be V upon I. V, what is V? V is given as 220. Upon what is I? I is equal to 100 upon 220. So 220 ऊपर आ जाएगा. Okay, so 22 into 22, 484 ohms. 0 will cancel out. Okay, so now this is the resistance of the bulb. Okay, now what is the question out there? See, then what will be the power when it is connected to 110? Now V is equal to 110 volts. Okay, resistance is equal to 484, and we want to find power. Power is equal to, again you can see, power will be equal to V square upon R. Okay, V is given as 110 into 110 square hai, upon R is 484. Cancel out 11 44s are 2. See, this is 11 into 11 is 12100 upon 484. Cancel out by 11. 11 4s are 11 4s are 11 11s are. Okay, cancel out by 11 again. 11 1s are. Okay, 11 4s are. That is equal to 25 watts. Power, we are finding power. So power will be equal to 25 watts. You can see that these are all formula based. Okay, if you don't know the formulas, then you can't do it. For example, see this one out here, one formula. Okay, these formulas are also interconnected. It's not that they are not interconnected. They are all interconnected. Once you know one formula, you can find the other formula. You can find other formulas also. All right. See number 4 now. Here, number 4 says two conducting wires of the same material and of equal length and equal diameters are first connected in series and then in parallel across the same potential difference. The ratio of the heat produced in series 1 and parallel combination. You want to find the ratio of the heat. So see, first of all, the two resistors, okay, two conducting wires of the same material are equal diameter first connected in series. So see, if you connect them in series this way, okay, if you connect them in series, this is your R and this is also R, because they are made from the same material. See, it says two conducting wires of the same material, for example copper. Okay, equal length, equal diameter. Equal diameter means equal radius. Equal radius means equal area of cross section. सब कुछ equal है, तो उसका resistance will be also same. Therefore, they have same resistance. They have same resistance. Resistance of both the wires will be the same because their lengths are same, area of cross section is same, material is same. Therefore, and they are also of equal length. Okay, so therefore the resistance will be equal. So therefore resistance in series, when they are connected in series, will be R plus R, that is equal to 2R. This is when the two resistances are connected in series. Now when they are connected in parallel, okay, then 1 upon resistance is equal to 1 upon R plus 1 upon R, that is equal to 2 upon R. Or resistance in parallel will be R upon 2. उसका उल्टा कर देते हैं. Okay, so now you got resistance in series and resistance in parallel. Now you see the heat generated is given by I square. Okay, it is given as I square R into T. R into T. I square R into T. But you know that I is equal to V is equal to I into R. So therefore, see this, V is equal to I into R. So in place of I can put V upon R. So in place of this I am putting V square upon R square into R into T. Remember what have I done here? In place of I can put V upon R. See this formula. Okay. So now you cancel out 1R. I get V square upon R into T. Okay. So now it says according to the question in the circuit they are connected and then across the same potential difference. Matlab V be same hai. So if for 1 second, 2 seconds, the same amount of current will pass through it, V square is given as the same, potential difference is given as well. So therefore, H will depend upon what? H is inversely proportional to resistance. Okay, so now what you want to find is heat generated in series upon heat generated in parallel. Heat generated in series upon heat generated in parallel. Okay, so heat generated in series will be Rs and heat generated in parallel would be Rp. Okay, or this will be equal to Rp upon Rs, where resistance in parallel, resistance in series. Now what is resistance in parallel? Resistance in parallel is given as R upon 2. Okay, R upon 2. What is resistance in series? It is given as 2R. Okay, so you get R upon 4R. R cancels out, you get 1 upon 4. Okay, so the ratio of heat generated when the resistances are connected in series and when they are connected in parallel is 1:4. You can see this is very easy. Okay, once again, if you look at it carefully, okay, I'm not going very fast. I want to explain it to you. See, there are two resistors. Okay, both the resistors are first connected in series and then they are connected in parallel. So when they are connected in series, it looks like this. Now both of them are of equal length, equal area of cross section because their diameters are the same. So radius is also the same. So area of cross section, this thickness is the same. The lengths are the same. They are made of the same material. So the resistivity is also the same. And at the same time, since they are made of the same material, they will have equal resistance. So suppose the resistance of the first resistor is R, then the resistance of the second resistor will also be R. Now when they are connected in series, the resistance in series, total equivalent resistance will be R plus R, that is 2R. When they are connected in parallel, it will be 1 upon R, that is 2 upon R. Or resistance in parallel will be R upon 2. Now the heat generated is given by this formula. Okay, heat generated is given by H is equal to I square RT. In place of I, you can put V square upon R. Cancel R, V square upon R into T. Now it is also given that the potential difference is the same across the same potential difference. So V is also same. And if suppose the time is 1 second, 2 second, 5 second for both, that means time is also the same. That means H is inversely proportional to the resistance. So heat generated in series upon heat generated in parallel would be 1 upon Rs upon 1 upon Rp, or Rp upon Rs. Cancel out R, you get 1:4. All right. You can see, not difficult. You just have to be a little bit careful about how you use the formulas. Okay. Now let us see the next one. That was number 4. Now let us see number 5. Okay. Number 5 says, how is a voltmeter connected in a circuit? Okay, to measure. A voltmeter is always connected in C. Suppose this is your bulb. Okay, and this is your ammeter, and this is your key. Okay, plug-in key, and then you have this is your battery. All right, this is a simple circuit. This is a battery. This is positive, negative. All right, this way. Now this is your key, this is your ammeter. Positive to positive, negative to negative. A voltmeter, this is your bulb, a resistor. Any resistance wire or bulb or something. Voltmeter is always connected in parallel here. So this is your voltmeter. So voltmeter is always connected in parallel. It says, how is a voltmeter connected? A voltmeter is always connected in parallel in the circuit with the resistor. Okay, across the resistor in a circuit. So in any given circuit, when you want to measure potential difference across a resistor, see, remember, potential difference is measured across 2 points. Suppose these points are X and Y. Okay, these points are X and Y. Across these 2 points, you have got a resistor in the form of a bulb. Okay, so when you want to measure the potential difference across the bulb, across points X and Y, you connect the voltmeter in parallel with the bulb. Okay, that is how you measure potential difference. All right, now let us see the next one. Number 6. A copper wire has a diameter of 0.5 millimeters. Okay, so diameter is 0.5 millimeters. Okay, so radius is half the diameter. Radius is half of 0.25 or 0.5, that is 0.25 millimeters. Radius is always half of that. So now radius is this, but if I want to convert into meters, remember we should solve always length should be in meters. So radius will be equal to 0.25 divided by 1000. Okay, because 1000 millimeters is equal to 1 meter. Now we have converted into meters. So I can write like this, 0.25 into 10 to power minus 3. Okay, ये 10 to power 3 ऊपर आएगा तो minus 3 हो जाएगा. Or in standard form I can write 2.5 into 10 to power minus 4. This is in standard form. So if I want to make r square, उसको स्क्वायर कर देता हूं तो 25 into 25 will be 6.25. Remember 2 decimal places. So 6.25 10 to power minus 8 minus 4 है वो डबल हो जाएगा, so many meters. ये r square है. Alright. Now what else is given? A copper wire and resistivity. Its resistivity is given. Resistivity is given as 1.6 multiplied by 10 to power minus 8 ohm meters. Okay, this is given in ohm meters. Ohm meters, the resistivity. What will be the length of the wire to make resistance of 10 ohms? Resistance 10 ohms है. Length of the wire L वो निकालना है. What is the length of the wire? Okay. Now obviously you see the formula for resistance. We must apply the formula for resistance. Resistance is equal to resistivity of the copper wire into L upon A, where L is the length, A is area of cross section. Okay, so resistivity into length, area of cross section will be pi r square. Okay, area of this is a circle, area of circle is pi r square. So this is now resistance is given as 10 ohms. Resistivity is 1.6 into 10 to power minus 8. Okay, length we don't know, we want to find the length of the wire. Okay, pi is 22 upon 7 into r square. अब हमने r square निकाल दिया है. R square कितना है? 6.25 into 10 to power minus 8. Okay, now obviously minus 8 minus 10 to power minus 8 cancel हो जाएगा. Alright, so 10 is equal to 1.6 into L. ये 7 है, ऊपर आ जाएगा 7. Alright, and नीचे क्या बचेगा? 22 into 6.25. Okay, so now L, therefore length of the wire would be 10 into 22 into 6.25 and नीचे आएगा 1.6 into 7. Okay, so therefore L, length of the wire, will be equal to 220 multiplied by 6.25 upon 7 6 are 42, 7 11.2. Okay, so the length of the wire, now all you have to do is find out by multiplying and dividing. Okay, so 220 and multiplied by 6.25, and that is equal to 1375 divided by 11.2 divided by 11.2 gives you 122.7678, 122.7678, so many meters. Up to 2 decimal places लेना है तो 122.77, 76 will become 77, up to 2 decimal places. Okay, so what will be the length of the wire? The wire will have to be more than 122 meters. काफी बड़ा लंबा वायर चाहिए, तब जाके 10 ohms का resistance होगा. Also it is said that how much does the resistance change if the diameter is doubled? Now see, if the diameter is doubled, if the diameter is doubled, मतलब diameter को double कर देते हैं, then how much does the resistance change? Now if you can see resistance, okay, resistance is equal to rho, that is resistivity upon L into A, or resistance is equal to rho is a constant, okay, length upon area of cross section pi d square, where d is diameter. Okay, अब so remember अगर d लिखना है तो d radius की जगह पे, okay, see radius is half the diameter, radius, so इसकी जगह पे अगर d square करता हूं, okay, remember this will be, in this case diameter will be actually twice the radius, okay, or radius will be half the diameter. So therefore rho into, okay, 1 upon pi d square है, pi d square and r. So therefore this is a constant, this is a constant. R varies with d square, the square of d. Okay, so remember d is diameter here. Okay, so diameter square. So अगर diameter को double कर देता तो 2 का square क्या होगा 4. So that means radius will be equal to, in this case 1 upon d है तो 1 it will increase, how many times it will decrease 1/4. तो 1 upon 4 हो जाएगा, 1 upon 4 if it is doubled, and d square this way. So therefore you can say the resistance will become 1/4, becomes 1/4. Okay, so remember resistance is equal to P, that is rho into L upon A. A is pi into diameter square. But remember, see, just to clarify this, actually क्या है, area of cross section, just write it out here. Okay, just here, area of cross section is pi r square. Okay, pi into radius. Radius is actually half of diameter square. So pi d square upon 4. Okay, so pi d square upon 4. So that इसलिए अगर ये 4 होता है, okay, then अगर diameter को maintain करना है तो 4 इधर लगाने पड़ते हैं, तो 4 pi d square, and therefore it will become 1/4. So again, if you don't want to do all that, just think like this. Pi d square है, okay, diameter is this thing 4 times, okay, so diameter is doubled, so this will become 2 out here, 2 2s are 4, so it will become 4, but नीचे 4 आएगा, so it means resistance will decrease by 4 times or 1/4. All right, that was number 6. Number 7. Number 7 says the values of current I and flowing, the values of current I flowing in a given resistor and the values of potential difference are given. Okay. Now if you plot a graph, you see we are given here I amperes and we are given V volts. 1, 2, 3, 4, 5. 1, 2, 3, 4 and 5 values are given. All right. This is a table which is given. The table is given to us. 0.5 amperes, 1 ampere, 1.5 ampere, 2 ampere, 1 ampere, then after that it is 2 amperes, then 3 amperes and then 4 amperes. All right, and this is given as 1.6, 3.4, 6.7, 10.2 and then 13.2. All right, this voltage and current are given. You want to plot a graph. Okay, जैसे मैंने जब Ohm's law explain किया था, okay, when I had explained to you Ohm's law, तब ये हमने ये table भी बनाया था, and I also showed you how to plot the graph. Here you see, in this case we will take volts. Okay, V volts हम लेंगे इधर, और इधर हम current लेंगे. Current here I in amperes. Amperes में current will be taken in amperes. Now you see, if you draw the plot, I told you will get a straight line. इसमें straight line graph आता है. Okay, you will get a straight line this way. Okay, this straight line and this way. इसका हम slope निकाल. This is called the slope of the graph. A, B, C. Okay, the slope of this graph is AB upon BC. AB upon BC. Okay, AB upon BC. Now AB क्या है इसमें? AB देखो तो करंट आएगा, करंट. ओके, दैट इज I. और BC क्या है? वोल्ट है, वोल्ट. ओके, बट वी नो दैट R is equal to, R is proportional to V upon I. Okay, R is proportional to, directly proportional. So ये उसका उल्टा हो जाएगा. So this will be equal to 1 upon R. Okay, that is reciprocal of resistance. It will be reciprocal of resistance. All right. So in this case now, when you take the ratio of this, that is AB upon BC, कैसे लेंगे? देखो, इसको यहां तक ले लो. Okay, this part, this will give you this. दिस इज योर BC एंड दिस BC विल बी इन वोल्ट्स। इसी तरह से इधर ये this will give you AB and AB will be in amperes and this ratio is called the slope. Okay, slope is AB upon BC, लेकिन वो क्या हो जाएगा, करंट अपॉन एम्पियर, करंट अपॉन वोल्ट्स आएगा, दैट इज करंट अपॉन पोटेंशियल डिफरेंस। उसका उल्टा करो तब 1 अपॉन R आ जाए, उसका उल्टा करो तो ही R आता है। ऑलराइट, देयर इज अनदर वे ऑफ डूइंग इट। यू सी द अदर वे ऑफ डूइंग इट इज एक्चुअली, ये देखो V कॉलम है, V का कॉलम, ये I का कॉलम में लेता हूं। ओके, नाउ सी V का कॉलम क्या है, 1.6 के बाद 3.4, 6.7, 10.2 एंड 13.2। ऑलराइट, I कितना है, 0.5। ऑलराइट, देन 1, देन 2, देन 3 एंड देन 4 एम्पियर्स। ओके, अब हम V R निकालेंगे। R इज इक्वल टू V अपॉन I अकॉर्डिंग टू ओम्स लॉ। Okay, so 1.6 upon 0.5, that is equal to, remember this will become 3.2, this becomes 3.2, this will be in ohms. Okay, ये volts में है, ये volts में, ये amperes में है, ये amperes में, और ये ohms में है। इसी तरह से 3.4 divided by 1 will be 3.4, 6.7 divided by 2, 6.7 divided by 2 is coming to 3.35. Okay, 3.35. Then 10.2 divided by 3, 10.2 divided by 3, it comes to 3.4. And finally 13.2 divided by 4, V upon I comes to 3.3. Okay, अब इसका मीन निकालो, x बार, सिग्मा x अपॉन n। n कितना है, 1 2 3 4 5, और इसका टोटल करो, 3.2, 3.4, 3.35, इसको ऐड करते जाओ। सो यू गेट 5, ओके, देन 4 and 5 6, 6 and 3 9 and 4 13 and 3 16, 3 3 6 9, okay, this is 1 2 3 4 5, 15 and 1 16, 16.65। अब ये 16.65 को 5 से डिवाइड करो एंड यू गेट 3.33 approximately 3.33 ohms. Okay, so that is how you get the, अगर इसका वैल्यू निकालो ने तो भी ये इसमें भी अगर निकालेंगे स्लोप तो भी ये 3.33 आएगा, 3.33 ohms. If you find out the slope, see, for this you require a graph paper. You have to do it on a graph paper, then find AB and BC, take the slope and 1 upon R. What you get will be 1 upon R. उसको उल्टा करो तो 3.33 approximately आएगा। और अगर ग्राफ से नहीं करना है, इसी तरह से करो और फिर मीन निकालो, उसका एवरेज निकालो। मीन मतलब एवरेज, दिस इज योर एवरेज, मीन जैसे स्टैटिस्टिक्स में निकालते हैं इसी तरह से। फाइंड द मीन एंड यू विल गेट द सेम आंसर। सो द क्वेश्चन सेज प्लॉट द ग्राफ and then find the resistance from it. So there are both ways of doing it. All right, so that is question number 7. All right, let's see question number 8 now. Question number 8. Question 8 says, when a 12 volt battery, okay, so potential difference is 12 volts. A 12 volt battery is connected across an unknown resistor. There is a current of 2.5 amperes, 2.5 milliamperes. मिलीएम्पियर्स मतलब कितना है, 2.5 10 to power -3 amperes. Remember, potential difference should always be taken in volts and current should always be taken in amperes. अब इसमें in this case we have got milliamperes. How much is milliampere? 1 milliampere is 10 to power -3 amperes. Okay, so 2.3 into 10 to power -3 amperes. Now find the value of the resistance. R हमको निकालना है। Okay, now according to Ohm's law, V is equal to I into R. Therefore, R is equal to V upon I. Okay, now voltage कितना दिया है, potential difference 12 volts. I कितना दिया है, 2.5 into 10 to power -3. देखो एक गलत हो जाता है अगर 10 to power -3 नहीं लेते हैं. You have to convert milliamperes into amperes and only then you have to solve the numerical. You cannot solve in milliamperes. Then the answer would have been wrong. Okay, so you get 12 or 120 upon 25 or 10 to power -3 will become 10 to power +3 ऊपर लेते हैं. Okay, now 25 4s are 100, 25 4s are 100, 20 left 200, 25 8s are into 10 to power 3, or you can say 4 8 and 3 zeros, so many ohms. अगर उसको किलो ओम्स में कन्वर्ट करना है तो 1000 से फिर से डिवाइड करो. So 48 kilo ohms. Okay, both answers are all correct. All three answers are the same. You can write any one of them, or you can even write like this: 4.8 into 10 to power 4 ohms. ऐसा लिखो तो भी ठीक है. It is the same thing. There is no difference whatsoever. Okay, so now this will become, sorry, this would be 25 into 4.8. Okay, so this becomes 1 and 4.8 kilo ohms. Okay, this will become 10 to power 3. All right, 120 divided by 25 is not 48, it is 4.8. मेरी गलती है. 120 divided by 25 is not 48, 4.8 into 10 to power 3, that is 4 and followed by 2 zeros, not 3 zeros. So you get 4.8 kilo ohms or 4.8 into 10 to power 3. A simple error. All right, now see in the 9th one out there. Okay, a battery of 9 volts, okay, a battery of 9 volts is connected in series with a resistor, okay, respectively. How much current would flow through this? Now you see it is connected in series. So the series resistance, the total resistance in the series will be 0.2 plus 0.3, 0.2 plus 0.3 plus 0.4, okay, 0.5 and also 12. So 12, 3 and 2, 5 and 4, 9, 9 and 5, 14, that is 13.4. 13.4 ohms. This is the equivalent resistance of the circuit. Okay, you want to find how much current will flow through it. I. Okay, how much current? The current V is equal to I into R according to Ohm's law. Therefore, I is equal to V upon R. V कितना है? 9 volts है. R 13.4 and so many amperes. So therefore, let us divide 13.4. Okay, 13.4 and divided by, sorry, 9 divided by 13.4. 9 divided by 13.4, and that comes to 0.67164. Up to 2 decimal places, 0.67 amperes. Okay, so the current passing through the circuit, okay, the current passing through the circuit, entire circuit. लेकिन हमको क्या पूछा है? We are asked how much current will flow through the 12 ohm resistor. But when resistors are connected in series, the same current passes. Okay, the same current passes. The same current passes through all resistors connected in series. So you can see all the resistors are connected in series. So the same current will pass through the 12 ohm resistor. It is asked what current will pass through 12 ohms. In fact, the same current 0.67 will pass through all the resistors. All right. So that is number 9. Now let us do number 10. Number 10 says here, how many 176 ohm resistors in parallel are required to carry a 5 ampere current? 5 ampere current. Okay, on a 220 volt line, 220 volt potential difference wali main line, main supply. How many resistors? Each resistor is equal to 176 ohms. How many resistors are required? You see, first of all, you see this is, suppose each resistor is, suppose the equivalent resistance. Suppose equivalent resistance is R. Okay, so therefore resistance of द लाइन, ओके, ऑफ द लाइन और यू कैन से सर्किट, ये जो सर्किट है मेन लाइन है उसका रेजिस्टेंस कितना होगा, R इज इक्वल टू V अपॉन I, ओके। नाउ व्हाट इज वोल्टेज, वोल्टेज इज 220, ओके, करंट कितना है 5 है, सो 44 ohms, ऑलराइट। नाउ ये पैरेलल कनेक्शन है, दे आर कनेक्टेड इन पैरेलल, दे आर कनेक्टेड इन पैरेलल। We are told that all the resistors, अब कितने resistors चाहिए, they are all connected in parallel. When resistors are connected in parallel, equivalent resistance decreases, okay. So the total resistance R of the circuit will be n times, okay, n times the resistance of each resistor, resistance of each resistor, okay, the resistance of the whole circuit. This is your RS, the resistance of the whole circuit, okay. I'm just calling it RS. You don't have to call it RS. This is the resistance of each resistor. So resistance, remember in this case the resistance of the circuit is 44, okay. We have just found out 44. N is the number of resistors that are required, and the resistance of each one, each resistor is given as 176, okay. 176 N into a number of resistors will be equal to 176. They are connected in parallel, isn't it? So this would be required to be changed slightly, okay. 44 is the resistance, okay, number of resistors into, remember now they were connected in parallel and each resistor is 176, so N into 176 or 44 is equal to R upon N, okay. You will get R upon N, therefore N will be equal to R upon 44, okay. R is 176, that is each resistor, okay, and N is equal to 44 and you get 4 resistors, okay. Now what does this mean? It means that 4 resistors each of 176 will be connected in parallel. How? See in this way. First of all, this way, this way, this and this, they are all connected in parallel, they are all connected in parallel, okay. This way, points X and Y, this is your point X and Y, this is also 176 ohms, this is 176 ohms, this is 176 ohms and this is 176 ohms. Now if you want to do it the other way around, see, अगर मैं इसको उल्टा करता हूं तो इक्विवेलेंट रेजिस्टेंस कितना होगा, 1 upon resistance when they are connected in parallel would be 1 upon 176 plus 1 upon 176 plus 1 upon 176 plus 4 है इसलिए 1 upon 176, okay. उसका LCM ले लो 4, okay. 176 is LCM, okay. 176 का LCM हो गया. Now all of them are 1 plus 1 plus 1, 4, okay. So resistance in parallel, okay, will be equal to R in parallel will be equal to 176 upon 4, that is equal to 44, okay. So you can see that this is there, that means each resistor of 176 will have to be connected in such a way that the equivalent resistance is 44 ohms. अब ये 44 ohms है equivalent resistance हो गया when they are connected in parallel. जब उसको पैरेलल में कनेक्ट करते हैं तब, ओके, सीरीज में नहीं है, पैरेलल कनेक्शन है. सो व्हेन दे आर कनेक्टेड इन पैरेलल, द इक्विवेलेंट रेजिस्टेंस अकॉर्डिंग टू द क्वेश्चन, हाउ मेनी 176 रेजिस्टर्स, ओके, will be required to be connected in parallel, okay. How many of them you will require to connect into? That means 4 resistors will be required to connect in parallel, okay. देखो इसमें फॉर एग्जाम्पल दिस इज एक्स एंड वाई, 176 का एक, 176 का दूसरा, 176, 176, चारों को पैरेलल में किया तो इक्विवेलेंट रेजिस्टेंस कितना निकला 44. हमारा इक्विवेलेंट रेजिस्टेंस देखो कितना है 44 ohms. रेजिस्टेंस विल बी द रेजिस्टेंस ऑफ द होल सर्किट. यू माइट आस्क के इधर सर 1/R क्यों नहीं लिखा? 1/R इसलिए नहीं लिखा, ये तो रेजिस्टेंस ऑफ द सर्किट है, पूरा सर्किट का. सो अकॉर्डिंग टू ओम्स लॉ R इज इक्वल टू V/I. ये 44 ohms पूरे सर्किट का रेजिस्टेंस होना चाहिए, लेकिन हम इसको पैरेलल में करने वाले हैं. तो therefore कितने कनेक्ट कर सकते हैं? So therefore obviously the number that you can correct will be 176 upon 44. 176 upon 44 will give you exactly 4. So 4 resistors will be connected in parallel and you will get 44 equivalent resistance. 5 एम्पियर का करंट होगा और 220 वोल्ट्स का पोटेंशियल डिफरेंस होगा. Alright, so that is enough for today. Okay, now there are still 7 or 8 questions left which I should be able to finish tomorrow and finish the electricity. As I promised you that we will do all, we will discuss all the questions and I won't leave out any numericals, especially numericals. The other part is very easy to learn. But physics, derivation, I have told you Ohm's law, okay, resistance connected in series, in parallel, Joules law of heating, these 4 derivations plus these numericals, you have to do them, you can't avoid them, okay. Meanwhile, please like the videos, share them, and above all, write your comments also. You are welcome to ask questions also. Some of you are writing nice things, that's very good of you, but if you have a question, that is also welcome. Thank you and have a nice day.